Today I'll solve heat equation by using Crank-Nicolson method. So here is the heat equation problem. 16 dou u by dou t is equal to dou square u by dou x square. So that is given. Now here is the boundary and initial condition that's are given. Initial condition ux comma 0 is equal to 0, 0 less than x less than 1. So here domain is 0 to 1. And boundary condition is also boundary condition are also given. So u0 comma t is equal to 0, t greater than 0, so that is left boundary fixed at 0, and 0 1 comma t, that is equal to 100t, so t greater than 0, right boundary linearly increasing with time. Now here is the objectives is solve using Crank-Nicolson with Gauss-Seidel method for 2 time step with lambda is equal to 1. Now here, so we have to modify form of the equation. So here this is the heat equation. So modify form is dou u by dou t is equal to 1 by 16 dou square u by dou x square. So the diffusion coefficient is alpha is actually 1 by 16. So means we can write like that, dou u by dou t is equal to alpha dou square u by dou x square. So here alpha is 1 by 16. Now discretization parameter, let's use the following discretization. So partial step del x is equal to 0.25, means 5 partial nodes including boundaries, and here lambda is equal to 1. So according to the Crank-Nicolson equation, so lambda is equal to alpha del t by del x square. So alpha is given and del x we choose that 0.25. so from here del t we can find, so alpha is equal to 1, del x 0.25 whole square by alpha 1 by 16, we'll get that del t is equal to 1. This time step del t is equal to 1. So two time step we have to calculate the interior node, so that t1 is equal to 1 and t2 is equal to 2. Now here is the computational grid and boundary condition. So here this is starting from x is equal to 0, then x is equal to 1 here. So in between 3 interior nodes are there, and t is equal to 1. So these are the interior node, t is equal to 2, another 3 interior node. Okay, now here that unknown at t is equal to 2 and unknown at t is equal to 1, we don't know. So boundary values, these green, these are given, and initial values are also given. So initial condition ux comma 0 is equal to 0 means all these values are 0, so that is initial condition. And partial grid xi is equal to 1 into del x, so this is I is equal to 0 1 2 0 1 2 3 and 4, so del x is equal to 0.25. time step tn, n is equal to del t, so n is equal to 0 1 2 because we have to calculate only 2 steps, so here del t is equal to 1. And boundary condition is given, so here u0 comma t is equal to 0, so this boundary and these boundaries are given, and here this boundary and this boundary also given in the boundary condition. So u0 comma t, that is 0, so these two values are 0, and here u1 comma t 100t, so that is also given. So if I calculate t is equal to 1, so that nodes will be 100 and that node will be 200. So now if you see the picture, visualization of the computational grid and boundary condition, so everything is given here. So t is equal to 1, t is equal to 2, and these are the initial condition, all are 0. These are the boundary condition, that is given 100 and 200, and these are the again that boundary condition that is also given in the boundary condition. So we have to calculate u11, u21, u31, these we have to calculate, and again at t is equal to 2, we have to calculate this one, u12, u22 and u32. So here that at t is equal to 1 we have to calculate these 3 nodes, at t is equal to 2 we have to calculate 3 interior nodes. Now so Crank-Nicolson formulation, so Crank-Nicolson equation lambda is equal to 1. Okay, so already earlier video video I already derived the equation. So it is a special case. So if lambda is equal to 1, so substituting lambda, we'll get this equation. Now from this equation, so if I reorganize, we'll get this equation. So now here using this equation means taking this equation, now we have to solve this interior node value. So for this we have to use Gauss-Seidel method. In the Gauss-Seidel, we use the most recent computed value for u I minus 1, n plus 1, and keep the old estimate for n I plus 1, n plus 1 until it's updated. Okay, so this the equation. Using this equation we have to solve. Now here, so this is the equation. If you see that node point, so these are the tn time, okay, and this is tn plus 1. So now if I want to calculate this value, if you see that this value, so we need all this neighboring node. Okay, so we need this node, summation of all these 4 node divided by 4, we will get this. So here solid green already updated, dash amber from the previous iteration, so we will get that. A red known values from tn and updated order from left to right. Okay, we will see that. So now here the initial value at t is equal to 0 we know already, so all are 0 from the initial condition, and boundary condition t is equal to 1. So from boundary we know this value and that u01 and u41 that is given. Now here, so again, so this is the when we take the lambda is equal to 1, we will have this equation. Now from this equation we can get 3 equation, so that 3 equation will use Gauss-Seidel method and we will get the node value. So here that u11 is 1 by 4 u01, u21 u00 and u20, u21 1 by 4 u11 plus u31 plus u10 plus u30, u31 1 by 4 u21 plus u41 plus u20 plus u40. So now here is the computational grid. So these are the boundary and initial condition. Now if we want to calculate this value, so I need this node value, this value, this value and this value. So if you see here, so this and this, if you see here, u11 1 by 4 u01 u01, so here this is u01 plus u21, so this is u21, u00 this is u00 and u20 this is u00. So but we don't know this value. Okay, now if I calculate this value, means if I calculate this node, if I calculate this node, we need this value, this value, this value and this value. If you see here, u21 is nothing but u21, so that is nothing but 1 by 4 u11, so this is u11, u31 this is u31 and u10 is this one and u30 that is this one. Okay, so if I want to calculate this value, so we need this and this, so we'll get this one. Now if I calculate next value, next 3 this one, so I need, if I want to calculate this, I need this node and this node. Already this node is there, so here 1 by 4 u21 is this one, u41 this one, u20 is here and u40 is here. Now if you see here, if you see here, so u01 is boundary value, that is already given, that is nothing but 0, and u00 that is also 0, and u20 that is also 0. Only u11 is nothing but 1 by 4 u21, so we don't know this value. Okay, u11 this value, u13 that we don't know, u01 is u01, so this is actually 0, and u30 that is also 0. Similarly u31 1 by 4 312 this is, sorry, 1 by 4 that u21 we are going to calculate this one, so u21 that is we don't know, u41 we don't know, u20 is here, u20, this one. So this is 0, and u04 is 0. Okay, now these are the equation, and u41, this is the boundary values, already we know, that is 100. So now using this, okay, so 3 equation, and here 3 unknown, other values are known. Okay, so we use Gauss-Seidel method. So Gauss-Seidel method, what we have to do, first you have to take initial guess. So initial guess here, u11 is equal to u21, u31 is equal to 0. Now if I plug that u11 in this equation, because this is unknown, okay, if I plug that, so that will be 0. Now similarly here, so these are 0, these are 0, and we got u11 0, and u13 that initial guess is 0, so u21 also 0. So here you can see that, so that is also 0. Now u13, so here you can see that here this is 0, this is 0, this is 100, and this is u12 already calculated, updated value 0. So now if I do that, so here you can get that 0, 100, 0, 0, so that is 25. Okay, so first iteration, so we'll get this, so 0, 0, 25. So similarly we have to go for second iteration, we will take all this value and do that. So similarly u11, if I plug that, so that will be 0. Now u21, because we got that u13 here, u13, so we have to plug that in the second iteration. If I plug that in the second iteration, so that will be 6.25. Now again u13, so that if you see the equation here, this we know right now, this is 100, so next iteration will be like that, 1 by 4, 625 plus 100 plus 0, 0, so it will be 26.5625. Now similarly if I do the continue the iteration, so third iteration, so u11 1 by 4 0 plus that 6.25, so it will be like that. Similarly u21 will be this, and similarly we can calculate the u31. Okay, so now here you can see that, so if I do like that, after 6 iteration we'll get this final value, because two Gauss-Seidel, two consecutive value will be the same. Okay, so we'll get that. Okay, so now here that the solution converts to this, u01 will be this, u11 will be 1.760, u21 will be 7.188, u31 will be 26.22, and u41 will be 100. Now if you see that computational grid, so now we got this value, this value, this value, and this is the boundary condition. Using this value, we'll get similar way we can calculate these 3 values. So now here again, so we get that 3 equation again. So for this we need this, and this. So this is the equation 1. For this, for calculating this, we need this one, and this one. So that will be the equation 2. And for this, if I want to calculate this value, so I need this point, this point, this point, and this point. So that will be the equation 3. Now here already we got this value, that will be the initial value we already got, we can use that. Okay, and the boundary condition we know. So these 2 point we know, this point and this point we know. We have to calculate these 3, and this all this value we know. Now here, so we get the 3 equation. So here we get 3 equation, okay, and 3 unknown, and other. So this 1, 2, 3 are unknown, other we know. So now again we have to use the Gauss-Seidel method. So for that we have to take the initial guess, that here initial guess is u12 is equal to u11, u22 is equal to u21, u23 is equal to u13. So using that we can calculate u12, u22. So u12 will be, if we plug that, you will get this value, u22 will get this value, and u23 will be this value. Similar way, if we do the calculation, second iteration, okay, now if I calculate, so finally after converging the value at t is equal to 2, we will get that u21 is this, u22 is 23.59 and u23 will be 17.39. so now this is the final summary. So this is the node, this is the that facile node position, and t is equal to 0, that is all 0 0, and t is equal to 1, so this is the value, t2 is equal to this value. Now if I plot that, so it will be like that. As time progresses, the solution evolves from initial 0 condition toward a curve profile influenced by the time dependent right boundary condition. So that will get. So if you see, because here this the boundary condition linearly increase this that u value, because of that this value will influence. Okay, so because of that we are getting slowly that it will be increasing like that way. Even if you go for third time state, it will be like that, fourth time state, it will be like that. Okay, so this may be t is equal to 3, t is equal to 4, t is equal to 5. Okay, so when time progress, so that other interior node will influenced by the right boundary condition. So that's it. Thank you.